Hi everyone, welcome back to my YouTube channel. My name is Veronica, but online I'm known as Data Geek is my name. If you are new here, please consider subscribing to my channel and turn on that notification bell because every single week I upload videos on step-by-step tutorials that will help you with your data analytics using Python, Power BI, Excel, and even SQL, all step-by-step. And in today's video, we're going to be cleaning messy data using Python and the libraries NumPy and Pandas, and a few tricks that will make your workflow a lot smoother. So make sure to stay till the end. Have you ever opened up a CSV file or an Excel file and saw some weird symbols such as blanks or inconsistent dates? Well, this one's for you. So let's get started. Right now we're looking at a data set. We see dates, region, products, category, units sold, unit price, total sales, and profit margin. So these are our column names. As you can see, looking at the data, the date is inconsistent. We have January 15, 2024, which is a long date. Then we have 1/30/2024. So these are things we're going to fix. Also looking at our data, under units sold, you'll see 32, 72, and NaNs. So we have non-values. And then we also have text that says 30, 20. So we're going to fix those as well, making them numeric. Then there's unit price. So you can see USD 858. And then there's the dollar signs. And then there's some that with no dollar signs, just a decimal. So these are things we're going to be quick and easy to fix using Pandas with Python. So total sales, also NaNs. And then profit margin, you see 10%, then you see the 15, and then text 15%, and then 0.8. So a lot of inconsistent data here. So we're going to upload this into Jupyter Notebook. So I will see you there. Before we jump into Jupyter Notebook, I want to show you Anaconda Navigator. So I use Anaconda Navigator to use for my data analytics. They have so many tools in here. There's Jupyter Notebook, with which I will launch. You scroll down, you have R, there's Jupyter Lab, there's so many different ones. So if you have not downloaded Jupyter Notebook yet, I suggest that you download Anaconda Navigator. You don't have to even download Python. It has it already in here. So once you download Anaconda Navigator, then you will have access to these tools instantly. I created a video on how to download Anaconda Navigator step by step. I will link that in the description below. So let's launch Jupyter Notebook. All right, so here is Jupyter Notebook. So once you're here, you can hit upload, and then you upload that CSV file from your computer, go to your file location and click on that data set. So this is the data set we just reviewed. I will have this data set for you guys in the description below. Once you open this up and download it into your Jupyter Notebook, you can follow along. Then you hit open, but I already did this step, so I'm going to scroll down. As you can see, here it is here, messy sales data. Now we're going to go ahead and create a new workbook. So you click on New and then Python Anaconda, and that will open up a new workbook. But in this case, I already created a new workbook with each step that we're going to be going along with. So in step 1, we're going to import our libraries. Step 2, load the data set. Then we're going to check for missing values and information. Remember, we kind of viewed the data, so we're going to handle some missing values, NaNs, which we saw that in our data set. And then we're also going to make sure that the numeric columns are actual numerics before filling any NaNs. Then we're going to fill missing numeric values with the column mean. And then step 4, we're going to clean column names, removing leading trailing spaces. Step 5, we're going to fix date formats. So again, we saw those dates that were unformatted. We're going to fix those. Step 5, we're going to standardize text and columns. So make names consistent and neat. And in step 7, we're going to convert units sold to numeric, turn words like 20 into NaNs. And then step 8, we're going to clean current columns, unit price, total sales. And step 9, there we go. So step 9, we're going to fix profit margins. Some values are like 10% and other ones were 0.1 or an 8%. So let's make them consistent. In step 10, we're going to drop rows with missing key data. So we're going to clean final data set. Step 11, we're going to check clean results. After we clean all of it, we're going to check it, right? Step 12, 13, and 14, we're going to do visuals. We're going to do total sales by region, sell trends over time, and category share pie chart. So we will be doing a lot in this video. But just to let you know, before we analyze data or build any visualizations, you need to make sure your data is clean. Think of it like this. If your data has typos, missing values, or duplicate rows, any insights or reports you create will be inaccurate. So data cleaning helps remove errors, fixing formatting issues, and make sure everything is consistent. So in short, clean data means trustworthy results. And that's what makes you a reliable data analyst. So let's get started. So I will add a cell under here. So first step, we're going to import our libraries. But first, I import my warnings. So any warnings that it gives us, you want to just ignore. Pandas, NumPy, Matplotlib, and Seaborn. Think of these as your data cleaning toolkit. Pandas helps organize and clean the data. NumPy does math and calculations. And Matplotlib and Seaborn make our charts and visuals look amazing. All right, so then we will run this code by hitting this play button. Or you can do, if you're using Windows, which I am, you'll do a Control-Enter. And this little asterisk sign, now it turned into a number. So your libraries are now ready. So now we'll go to step number 2, which we will load the data set. And add a cell. So now we're going to load this data set. So again, we already uploaded the data set into Jupyter Notebook. But now we want to load it in here into our code so that we can view the data set on here to analyze and clean the data. So we will go ahead and use the Python code. It's going to be df equals. So this is what we're calling our data set. So this is the name of our data set through this tutorial until we clean it. So then once we clean it, we want to rename it to clean data set or clean df. So df equals, and then here's our pandas library, which we're going to be using this pd.read underscore CSV, open parentheses, double quotation, messy underscore sales dot CSV, double quotation, close parentheses. So this line of code here is reading our data set. So this is part of pandas library. And messy sales underscore sales.csv, that's our CSV file name. So if you have a different CSV file name, you will replace that here. That's how we pull in our data set to read it. So now we want to view the data set. We want to see the first 5 rows of our data set, but in this case, we're going to do 10, and I'm going to show you how to do that. So we're going to do df, which is our data set name, dot head, then open and close parentheses. Now I'll go ahead and run this. So here's our top 5 from our data set. But if we want to see 10 rows, just click into that open and close parentheses and put 10 and run again. And now there's 10. If you want to see 15 or 20, just change that number there. But here is our data set, and this is what we viewed at the beginning of this video. You will see again, there's inconsistencies of date. There's NaNs in here for units sold. There's some numbers and text under units sold. Also margin. So everything we saw at the beginning. So this step is important because you want to look at your data set. You want to make sure your column names are correct. Looking at any NaN values. Just good to view your data so you know what to expect on your next steps going forward on what you need to clean. So in step 3, we're going to check for missing values. It's just a very simple code. So df, which is our data set name, info, open and close parentheses, and we will run this. So here we're checking for any missing values. This is the core pandas data frame. And here you'll see 200 entries. There's 8 columns. Here's your column names. Then there's non-null count. And then there's data types. So we can see there's 200 non-nulls in date, region, and product and category. But here it says units sold. So it should add up to 200 for non-nulls. But since it's not adding up to 200, there's 196 that are non-nulls. So there are some nulls in there, about 4 of them in there. To look more at more detail of those nulls and the count, we will go to step number 3.5, so handling misses and NaNs. And we will do a df.isNull, open and close, parentheses, and we want the sum, S-U-M, open and close parentheses. And we will run this code. Now we have our column names with the actual number of those null values. So again, we saw up here 196 non-null, but there is 4 null. Total cells, 3, just as we guessed. So before we move on, it's important to ensure numeric columns are numeric before filling NaNs. So when we create visualizations in Python, numeric values are essential because charts and graphs rely on numbers to display patterns. So libraries like Matplotlib and Seaborn use these numbers to calculate things like averages, trends, and comparisons. So if your data is stored as text instead of numbers, Python can't plot it correctly. So you'll just get blanks or inaccurate values. That's why converting data to numeric values is one of the most important steps before visualizing. And we will do that step next. I'm going to run this and add a column. First step, we're going to do df, which is our dataset name, open bracket. Then we're going to do units sold. So here is our column units sold. So we want to change that to numeric since we're going to be filling the NaNs. And then also we're going to do the same thing for total sales. So units sold and total sales. So we're going to start off with df, which is our dataset name, and then open bracket, and then a double quotation. And then we want units sold. Close the double quotation and close that bracket. Then we're going to equal this to pd dot to underscore numeric, open parentheses, df, again, that's our data set, open bracket, and then our column name again. So units, make sure it's spelled correctly, otherwise you'll get an error. Units sold, double quotation, and close bracket, and a comma. So errors equals double quotation, COERCE, double quotation, close parentheses. Now we're going to do the same exact thing, but for total sales. All right, so we'll go ahead and run this. And it gave us a number, so it ran successfully. So now we're going to fill missing numeric values with column mean. So this is how you will be able to fill any missing numeric values. Sometimes a good practice is just to fill your numeric values with a mean. So we're going to do this for both units sold and total sales. So we do a df, open bracket, double quotation, again, units sold, double quotation, close that bracket, equals, and this time we're going to do df, open bracket, double quotation, and we're going to do, again, units sold, because that's our column name, dot, fill, NAs, or NA, open parentheses, df, open bracket, double quotation, units sold, close that bracket, dot, and we're going to fill it with a mean, M-E-A-N, open and close parentheses, and then close that parentheses again. So this is the line of code to change that units sold column, any NAs at all, will be replaced with a mean. So we want to do the same thing for the next column, which is total sales. All right, so then looking at this, I see that units sold, making sure everything's spelled correctly. Here I have a lowercase, so even if it's lowercase, it's going to give me an error, so I better make sure that's an uppercase. So units sold, Everything's spelled correctly. Total sales, total sales, total sales. Okay, so let's run this code and see if it runs successfully. And it did. It gave us a number here. So now those NAs should be filled with a mean. So next step, step 4, we're going to clean column names. So we're going to be removing leading trailing spaces. So we're going to go ahead and run this and then add a column. And that code is very simple code. So we're going to do a df dot columns equals df dot columns dot str string, and then we want strip strip and open and close parentheses, and that is it. So many datasets have hidden spaces or weird characters in column names. So we'll remove these using one simple line of code, which is this one here. It's small, but trust me, it saves a lot of future headaches. So very simple and easy to use. I'm going to go ahead and run this, and it worked. It ran successfully. In step 5, we're going to turn inconsistent text into real date format. And again, a real simple line of code. So df, open bracket, and this is going to be our date column, equals pd.to underscore date time, open parentheses, df, which is our data set name again, and we want to open bracket, double quotation because we want that column date, close bracket, comma, errors, equals, double quotation, COERCE, double quotation, and close parentheses. Simple line of code here. Dates can be tricky. Some show us text, others have slashes or dashes or just weird stuff, right? So Pandas can automatically convert these into proper date formats using the pd.to underscore date time. So we'll go ahead and run this. Oh, it says here, it gave us an error. So this bracket, open bracket, was never closed. So this date. So df, open bracket, double quotation, date, and close that bracket. So let's try this again. It gave us a number, so it ran successfully. Step number 6. We're going to standardize text columns, make names consistent and neat. So if you notice things like north with a lowercase n versus north with an uppercase n, or say you see something like a space and then west with spaces, that's messy text data. So using the .str.title, open and close parentheses function, we can make everything consistent. Super useful for grouping data later. So we'll go ahead and run this. And it ran successfully. So now step number 7, we're going to convert units sold to numeric. So we're going to turn words like 20 into NaNs. So this one line of code should be able to fix that. So some columns like units sold or total sales might look like numbers, but are actually stored as text because of commas, dollar signs, or words like USD, which we saw at the beginning of our data set. So we're going to clean them up using the pd.to underscore numeric. So this line of code will do that. Let's run this. And it ran successfully. So I'll go ahead and go to step number 8. We're going to clean currency columns. So we're going to do unit price and total sales.
In this step, we're cleaning our currency columns, like unit price and total sales. Sometimes these columns contain symbols like dollar signs or commas, which make Python think they're text instead of numbers. So here, we're moving those symbols and converting the columns to numeric values, allowing us to perform calculations and create accurate visualizations later.
So here's the code for that, and I will run that. And I got an error, so unit price. So see how I put a lowercase? So going back up, so for columns in unit price, so making sure it's spelled exactly as it is in your data set. So we need a capital U. So we'll run this again. And it ran successfully, 15. So it gave us a number. So now we will go to step number 9. So step 9 is we're going to fix that profit margin. So remember that column had a bunch of like 10% or 0.10 or 8%. Well, we're going to make them consistent. And this is the code to do that. So profit margins sometimes come as percentages, decimals, or even words like 15%. We'll make them all numeric and consistent, turning everything into real percentages so they can be analyzed properly. So in this step, we're cleaning the profit margin percent column. First, we remove any symbols like the percentage sign or word percent so that Python can recognize the values as numbers instead of text. Then we convert the column to a float data type. This allows us to perform calculations later. And finally, we make sure that any profit margins written as decimals, like 0.25, are correctly converted to percentages by multiplying them by 100. So we will go ahead and run this code, and it runs successfully. In step 10, we're going to drop rows with missing key data. So we're going to clean the final data set. And this one's easy. It's going to be one line of code, df_cleaned equals df.drop NA subset equals open bracket, double quotation, the date column, double quotation, total sales column, double quotation, region, double quotation, close that bracket, close the parentheses. So we're going to drop any NAs within these columns. So we'll go ahead and run that, and it ran successfully. Now step number 11, we're going to check cleaned results. So now that we're done, we want to check our results. And just like we did before, so we're calling this df cleaned. So it dropped the NAs, but it's also identifying this df dataset, and we're renaming it to df cleaned. So that's why we're going to do df_cleaned, and we want to check the head of our dataset. And we will run this code. And here is our cleaned data set. So now you can see that north, south, west, products, category, units sold don't have any more NaNs. So even if we do like say 15 here and run this and see 15 columns, now you can see that it's all consistent. There's no more NaNs, there's no more inconsistency of like numerics and text. Looks really good. So now we are ready to visualize our data. So these are the fun parts, the visualization. It's going to be plt.figure, open parentheses, and it's going to be fig size. And we're going to equal that to, open parentheses, 8, 5, and then close those parentheses. Next line is going to be sns.barplot data equals df, which is our data set name. So now it's df_cleaned. So we want to see the cleaned data, comma, and we want our x-axis to be the region column. And then our y-axis to be our total sales column. And the estimator is going to be a sum. So we're going to see the sums. We want this to be like a cool color. Close that parentheses and plt dot and then title. So let's see, what should we title this? We should title it total sales by region. Yeah, let's do that. And then we want our font size to equal 14. plt dot x ticks, T-I-C-K-S. And then rotation equal 30. All right, so now we'll do plt.show, open and close parentheses, and we will run this. And here is our first chart. So now we have total sales by region. Very cool colors here. So we have north is blue, south is like a darker blue, west is purple, and east is like a brighter, I guess, purple. Here's our total sales here on our y-axis and region on our x-axis. So looking at this, what is our highest sales here? That is correct, north. North is our highest sales, and the lowest sales is east. Looking good. Now step number 13, add a cell here, run this one. Now we're going to do sales trends over time. So as you can see, the kind of chart, I'm doing a line chart, and I want it to be a teal color. So let's run this to see our line chart. And here is the line chart. So again, it's going to be sales trends over time is our title. So let's see our sales over time. So here is our total sales Y label and our date. So we can see in January 1st, 2024, looks like it was here above the 50,000. Then it spiked down on January 15th. Then it went up again, stayed consistent, and then back down, and then a big jump up between the 1st and the 15th. So it looks really good. Looking at this, you can see our spikes here when they went up, and then our spikes going down. So now going to step number 14, we're going to do a category share pie chart. All right, so we will run this code. And here is our pie chart.
Now that we created our pie chart, you might notice something interesting. There are duplicate, or you can say inconsistent category names like elect, gadgets with an S, and electronics. So just to let you know, this happens a lot in real data sets where the same category is entered differently. So for example, maybe shortened, misspelled, or labeled inconsistently, which this happens a lot. So this step reminds us that data cleaning doesn't stop at missing values or symbols. We also need to make sure text categories are standardized. So sometimes these visualizations will let us know that, and taking a look at that, we have to fix those. So that in a real project, we'd fix this by replacing these inconsistent names so our visuals represent accurate insights. With all that said, that wraps up our data cleaning tutorial. As you just saw, even after visualizing, we can still discover small issues, and that's completely normal in real-world data. Cleaning is an interactive process that helps you get clearer, more accurate insights every single time. If you found this video helpful, don't forget to like, subscribe, and share it with someone learning Python or data analysis. My name is Veronica, known as Data Geek is my name. I appreciate your support, and thank you so much for watching. I will see you on the next video.